Q&A session. But if you have more questions, you can write down. We have another like 10 minutes at the end of the session. At the end of the seminar, you can ask your questions.
Okay, so I have started the recording as well, Vincenzo. You are good to go. Yeah.
Okay.
Great, thank you. So, welcome everyone. I'm very glad to be here as a speaker for this talk about digital twins in action. Today, I will present one of my latest work about how to integrate generative AI with digital twins, creating the so-called generative digital twin, spanning in the whole IoT Edge Cloud Continuum. So, as Barrett said, a quick introduction of myself. I'm Vincenzo Barbuto, a PhD student in Information and Communication Technologies at University of Calabria. Currently, I'm a visiting scholar at University of California, Berkeley. I'm IEEE member. I'm vice chair of this IEEE Student Branch at University of Calabria. I'm a member of the Smart and Pervasive Mobile Engineering Laboratory at University of Calabria, and focusing mainly on how to integrate AI into IoT systems, actually to enable real-time and efficient decision-making at the network edge. So I will provide a brief introduction about digital twins, describing the main components and the key properties of digital twins. And then I will provide to you a little story about the evolution of digital twin from the mirror world to AI-aided digital twin, focusing a bit on a specific AI-aided digital twin, which is the opportunistic digital twin, which was also part of my work. Then I'll also introduce how the design approach changed during the time from a model-driven to a data-driven, and then to an hybrid approach. And I will also introduce the concept of general digital twin, presenting its models architecture, application, and few deployment consideration. So what is a digital twin? A digital twin is an executable virtual model of a physical thing or system. So the key components, as you can see in the image, are mainly three: the physical object in the real space, the logical object in the virtual space, and most important, the data connection between the two of them. Why using digital twin instead of legacy traditional tools such as computer-aided design or the IoT system? Well, the former computer-aided design only live in the simulation world. There's no interaction with the real object using real-time data to evolve, but only in simulation world. While IoT system, typical IoT setup, we may have devices that collects data and send data to this centralized architecture, a centralized point, but there is not a lot of connection between the devices at the same level of the system. That's why we introduced the digital twin with the key properties such as representativeness and contextualization. We have to be able to represent in a very good way the physical object in the real space in the operational environment, and also contextualize such physical object with all its properties, properties such as reflection, but most of all entanglement, which is in my opinion, the most important one, which is the strong and intertwined connection between the physical object and the logical object, what actually we didn't have with the CAD, CAD technology. So a digital twin-based system encompasses the following components: sensors and actuators on the physical realm. So we are able not only to gather information from the real space, but also to actuate some decision made by the digital world. But how can we do that? By using data and analytics all in the digital sphere. And then there is this connection that bridge the two worlds, the physical and the digital one. But actually, the concept of this kind of software model, which is able to replicate real-world data, is pretty old. For the first time, appears in during the 1990s as a mirror world. In fact, in the first place, digital twin were a kind of software model able to simulate, but also just only monitor some aspect in product life management and aircraft management field. But at that time, there was a limited technology about how to deal with real-time data in unidirectional communication. Actually, this kind of technology didn't evolve a lot. But actually, in 2010, the term digital twin came out, thanks to the new advancement in wireless communication technologies, but most of all to the rise of Internet of Things. Internet of Things, in fact, gave the possibility to digital twin to have several properties and features such as data standardization, connectivity, and scalability. But also at this time, we are able to manage and deal with real-time and bidirectional data exchange, so that we can actually bridge the connection between the physical object and the logical object. We also had a few attempts in using early AI techniques for digital twin. So developing in this way digital twin not only able to predict and forecast future states of a physical object, but also to execute, so to react to the environment stimulus using decision-making techniques with the so-called predictive digital twin and reactive digital twin. But at this time of the story, actually, the design approach for digital twin was a model-driven approach. So we use physics-based models to simulate real-world behavior based on known system dynamics. This is a very reliable design approach, but this actually has several challenges, such as the high cost due to the need for expert knowledge. Think about, we want to create the digital twin of a smart building. We need knowledge about that. We have actually to spend money for people that actually have this knowledge. Then allow us to have time-consuming simulation and limited adaptability in dynamic environments. Think about IoT scenarios. They are very unpredictable dynamics. Maybe this kind of approach is not suitable for these use cases. So to overcome this issue, we decided to study how actually AI can empower digital twin to go beyond the digital mirror thing. Okay, and actually we understood that the AI can boost digital twin by giving them adaptive learning, in which in this case digital twin are able to actively learn from the pattern coming from the evolvable environment. We're able also to identify patterns, and through that we are able to enable proactive optimization and efficiency for our use cases. A first attempt of an intelligent digital twin was the so-called cognitive digital twin that uses AI to reason and autonomously analyze, adapt the real object, the virtual object in the logical space within the environment in which the physical object is actually placed. So we actually focused on a specific AI-aided digital twin because we actually studying the state of the art of the digital twin design approach and so on and so forth. We actually asked one question: what if we want to introduce more feature in our digital twin? So we know that actually we have sensors on the physical side that sense information and send it to the real to the virtual space. But what if we want to increase the number of sensors? What if we want to increase the number of features that we want to measure? Well, we have to place other sensors, increasing maintenance and deployment costs, which in some cases also increase the complexity of the system we are working with. So we actually designed this kind of approach in our one of our latest paper about the opportunistic digital twin, in which we exploit AI techniques to actually use the value that we already have and the sensor that we already have, and using the value gathered with AI techniques to create new synthetic values that can help us to measure specific features that we want to measure. So think about a situation like this. We have a set of sensors, maybe like all placed in just one general purpose sensing board. And we want to infer, for instance, the engine status without placing a specific sensor on the engine status. The engine status, so we can exploit the properties that we already have, so the values that we already have, and using AI techniques to infer, for instance, from the temperature and the CO2 sensor, the engine status. So in this way, the features of our digital twin are no longer set a priori, but they are flexible and they can evolve incrementally using synthetic value processed by AI techniques. But for this kind of approach, a model-driven approach, for this kind of digital twin, a model-driven approach is not suitable. So we actually decided to study a new kind of approach, the so-called data-driven approach, in which we actually leverage real-time data instead of physical-based models. Mainly, we use machine learning, deep learning techniques. And data, in this case, drives the decision-making and system simulation. It's a very nice approach in this case. But of course, also this approach comes with some challenges, such as it relies too much on black box AI. So we actually lose the explainability that we gain using a model-driven approach. Then we have to also to consider that usually like data come from edge device, and the quality could be very low, but also they can be insufficient for performing a specific simulation or for correctly modeling a physical object. So the solution we came out with was a kind of a hybrid approach. So we actually use the benefits of the model-driven approach to overcome the drawback of the data-driven approach, and vice versa. So the MDA, in this case, we're able to enhance all the accuracy using the structured models with the data-driven insight. We have a better adaptability because in this case, our digital twin can be elastic and flexible, but most of all, we have a balanced intelligence. So we combine the explainability from the model-driven approach with the flexibility of the data-driven approach. But we have to take into account another thing, that when we talk about AI-aided digital twin, we mainly talk about a specific kind of AI models, the discriminative one, that focus on distinguished data types, so the classical classification, clusterization, and so on and so forth. But these kind of models fall short in enabling a completely proactive approach. So we decided to explore the generative models and the so-called generative AI, which is able to assimilate patterns and structure from training data, serving as a source for creation of close to real world data. So in this way, we are able even to increase like the contextualization and the replication properties of the digital twin. We are able to extract useful insight from a limited low quality edge device data. And most of all, we reduce even more the reliance on numerous physical devices, enhancing the so-called general purpose sensing. So in this way, we are also able to understand both natural language using the generative models and physics-based simulation using the classical approach of digital twins. So the merge of generative AI and digital twins meets the so-called generative digital twin, in which we are able actually to create dynamically shaped system, elevates data quality, and facilitate a smooth interaction between human and digital twin, but also between digital twins. Okay, and in this case, the simulation becomes data-driven. So we are also able to give the possibility to our digital twin to learn from real-time data distribution. And of course, this kind of digital twin holds the potential to actually find applicability in several fields, such as healthcare, smart cities, industrial IoT, and so on and so forth. So in this table, we can see the difference between the classical digital twin and the generative one. So we gain in terms of adaptability and real-time modeling, because in this case, generative digital twin are dynamically shaped. We are also able to improve data quality. That we know that actually digital twins take data from sensors and edge devices, and they are usually prone to errors and lack reliability. But in this case, using generative digital twin, we are able to identify faults in multiple sensors. We are also able to improve data generation and augmentation techniques, the interaction with the physical asset and human operators, but most of all, simulation. In this case, simulation are not anymore human biased, but they become data-driven, providing a more accurate representation using the close to real data generation that we're able to gain. The models for supporting this kind of digital twin are the classical generative models. We actually study a bit about variational autoencoder with the capabilities of enabling probabilistic sampling and anomaly detection, but also generative adversarial networks that consist of a generator that creates samples and a discriminator that distinguish real from synthetic values in the subgroups such as Wasserstein GAN, conditional generative adversarial network, and time series one. And of course, the transformers on which large language models are based that excels in contextual data generation, but we have also to address some issues such as the high computational demands in the IoT world could be actually a problem. An example of first generative digital twin we tried to implement was in a smart city environment. Think about a digital twin that is able not only to mirror a specific crossroads, a road, and provide useful data about that, but it's also able to perform some AI techniques, such as the vehicle trajectories that we try to implement. So the aim was to predict some vehicle trajectories, to analyze this data, and then this data can be useful for traffic management. So we used the following hardware setup using an Edge AI-enabled board, which is the Google Coral Dev board, a general purpose sensor board, which is the environmental sensor board, an IP camera to get the video from the road, and then from the software part, we use discriminative model, let's say like classical AI techniques such as a long short-term memory module, and then we also add the generative AI parts, which is a transforming based, in this specific case is Roberta. So the idea was, what happens if when I gather data from the video, from the camera, maybe for lacks in terms of communication or lacks in terms of data quality, I receive corrupted data. Well, in this case, like our discriminative model, the LSTM, is not able to perform well at all. So we actually ask if the ground data that we gather are corrupted or not. If not, okay, we can use it as an input. But if yes, we, in this case, activate the generative models. In this way, we are able to reconstruct data and give this reconstructed data as an input for the LSTM. As you can see from the graph here, the red line is the behavior in normal condition. But what happens if we lose the 20% of the video data, or 30% of the video data, or 40%? As we can see, the GenAI reconstructed data empowered LSTM is overcome also all the LSTM that uses only partial data. So actually, this kind of approach works, and our vehicle trajectory use case benefits from that. Last consideration about that is that, guys, we need edge cloud continuum because we need to exploit all the benefits from the edge computing, which enhance responsiveness and reliability by processing data as close as possible to data sources, and the cloud computing that provides robust computational power for executing complex models and tasks, such as the generative models one, because we cannot use only the edge computing. We don't have enough resources for this kind of complex models, but at the same time, we cannot only rely on cloud, because we could have connectivity issues, network latency, and so on and so forth. And right now there is a current literature gap on how to place this kind of system across the network architecture. So to conclude, we saw that actually Gen AI can be can empower a lot digital twins by enhancing all its properties from contextualization to representativeness. And the new kind of approach, this hybrid approach in between model-driven and data-driven approach, can support this kind of generative digital twin system. Of course, we have few challenges ahead, such as selecting the right AI technologies depending on our use cases, how to integrate the data flow in between AI and digital twins to create a very good combination in between these two kind of technologies. And of course, investing. We have to spend money, guys. We have to invest in infrastructure, data management, and talent acquisition. But despite this, we strongly believe that generative digital twin have the potential to transform the IoT system, delivering very innovative solution, and most of all, intelligent across industries. So all these are on one of our latest work, which is generative digital twins and novel approach in the IoT Edge Cloud Continuum. And thank you everyone for your attention. And I will reply to your question if you have after Mustafa's presentation. Thank you very much.
Okay, thank you very much, Vincenzo. I think we can also take the questions at the end of Mustafa's presentation.
Yeah, that would be great because I'll be very quick as well. And yeah, if everything is fine, let me just share the screen first.
Yeah, please go
Okay,
on.
my screen is visible.
Yeah.
Yeah.
Perfect.
Okay, so yeah. First of all, I just want to focus on the main aim for organizing this kind of webinar. As an academic, I personally believe that first we faced industry 4.0 version, which actually encourages the enforcement of IoT. Then we gather the sensors, then we visualize the data. But right now, in today's world, we are actually focusing on industry 5.0, where we encourage human centric thing, or we can say human or robot based or human machine collaboration. So the idea was like very workable and very significant that I invite Vincenzo. Vincenzo is really good friend of mine. I met him in Erasmus mobility program during my visit in 2022 in Telecom Sud Paris, and since then we are connected somehow. So I saw his research is in this area, so I requested him, how about you talk about digital twin in a different perspective, and I talk about digital twin in terms of human robot collaboration. So since I'm working in IRC for aviation and space exploration in King Fahd University of Petroleum and Minerals as a postdoc, this is my brief introduction that I just want to brief that I have like number of good publications that are well recognized, and I'm about to cross the 500. I almost crossed 500 plus citations on Google Scholar, and yeah, as I said that I met Vincenzo in Erasmus plan. Right now, my main focus in on swarm technology of a drone, and maybe like I'm you can say that I'm working currently now on different control and observer techniques. So coming over the topic that is digital twin, as it was brilliantly clarified by my brother in his presentation. What do you mean by digital twin? Digital twin is something that you are creating a virtual copy of any physical system. For example, let me give you an example that in some of the countries, people are very reluctant to put their hands on robotic manipulators in the industry. So what we are doing, we are actually giving them a digital twin copy, or we are creating maybe a virtual reality or augmented reality based programs for them, so that they can, learn from their, exercises. Same goes for digital twin. We are actually creating a virtual copy of your system, and then we are analyzing that, okay, if we propose this thing, what will happen. So this is all about digital twin. And then when you have created the digital twin, then you can play around with adaptive control theories, you can play with data driven algorithms. In this presentation, what I will be focusing on it, I'll just review some of the work that is happening in control theory, and I'll be focusing on the significance why we need it for human, robot, or specifically in the domain of drones. So this is kind of a research background that I'll start with. I have already mentioned about digital twin. Now I'm jumping towards the drone that I'm just mainly concerned. This slide actually focusing on industry 4.0, as I said. What is the difference between 4.0 and 5.0? Now coming towards some mathematics of drone. Drone is something that can fly in the air easily, but there is a lot of mathematics significantly. If or particularly if I talk about differential equations, it won't be wrong. So if we talk about four quadrotor, like four motor based drone, which we call it quadrotor, it's under actuated system. So these two equations are actually showing that what do you mean by under actuated system. Without going into the detail of mathematics, let me just define it in a very lamb language or in a very simple language, that when you have four inputs and your physical system or mechatronic system like drone can produce the motion in six directions or six degree of freedom. For example, we have three angular accelerations, and we have three angular velocities, and we have three angular translational velocities. We have roll, pitch, yaw, and then velocity in x, y, z direction. So such system where you have degree of freedom is more than your control inputs, which is four. Such systems are under actuated and they are very unstable. We cannot control them easily. But at the same time, control engineering, proves this thing that if you propose a good control algorithm or such like adaptive control algorithm, then you can exhibit a natural dynamic motion of that mechatronic system. You can control it very well, and people are using under actuated system in different fields. If you take an example of satellite, your two thrust satellite is under actuated system. So until here I have described you what do you mean by digital twin, and what is the main topic that we are discussing is under actuated system. We can, and since under actuated system I have talked about, I'll focus on fully actuated system as well. Fully actuated system means if there are 6 degree of freedom, then you put six motors on a drone and it would be quite easy. But at the same time, it will utilize more cost, more power, and it's easy to control, by the way. But with four control inputs, four motors, if you are able to control it in a very natural dynamic motion, it would be really great. And you will cut the cost, you will cut the power. So it will be very easy. And people are trying to play with under actuated system for so many reasons. I gave you an example of two thrust satellite. We have several other examples as well. So why I'm in favor of using digital twin for quadrotors? Because there are several issues. One issue that I mentioned to you is under actuation. I'll recall some other issues, but before that, since I have started the story of under actuated system, I can recall one more example, that is under actuated hovercraft. Hovercraft mostly is used by military people. They actually transport goods from one place to another, and it literally hovers over any surface, whether it is sea, earth, or ice maybe. And we have two-wheeled robots. Right now, various universities, like top-notch universities, they are working on it. Recently I had been to Italy. I have seen over there the two-wheeled robots by different people, different universities. They have been doing research in that area. So this is known as, again, under actuated. So under actuation have four types. One is that is by default, and second one is due to an accidental effect, your one of the rotor or one of the input is no more, so that will turn into under actuated system. And third is under actuated systems, which are by default, or what we say, they are for just study purpose. For example, people who are from control engineering domain, they might know about ball and beam or maybe inverted pendulum. These are the systems that actually help us to evaluate the effectiveness of our algorithm. So whether it is classical control, whether it is robust control, whether it is modern control algorithm, or it is adaptive control, just like ANN or genetic or neural network or something else. So why I'm basically focusing on this thing, because quadrotor, since I'm the guy who is mainly into the drone, so we categorize some of the modeling issues of a drone. When we model, I mean, when we convert the physical drone into mathematical model, we have nonlinear dynamics. Then somehow we try to play with mathematical assumptions. We have rotor dynamics, and then we have aerodynamic effect, which is continuously changing. So that's why somehow people are working on data driven approaches as well. But the main thing is, how about the modeling approach? I mean, the thing is continuously changing in the sky, and how to control it. So for that purpose, digital twin can play a very vital role. Coupled rotational and translation. If you drive the dynamics of a drone, it will come in terms of cos and sine theta. So again, you have like rotational and translational dynamics, which is coupled strongly mathematically, and whatever theorem you are going to use, either you are using Gaussian, you can use our Ranji-Kutta method, or any sort of mathematical solution you bring it, it will be limited to certain condition. But once the conditions are changed, uh, you will face some sort of disturbances. Same goes with parameter uncertainty. I mean, there are some external disturbances and unmodeled dynamic factors. For example, you have modeled your drone for certain payload, but in the sky or during the operations, your payload is changed, or maybe the wind disturbances you categorize for certain limits, but now the wind, the environment is more windy than your expectations. So in certain scenarios, I believe digital twin plays a very vital role. Why? Because it enables you to see the things before you apply. And same goes for the disastrous things. For example, I was in Italy, and I listened one of the presentation. It was by Massimiliano from University Polytechnical di Bari, I guess, and he provided the digital twin of a drone that actually lands on inclined surface. So mostly what happens in the disaster situation, that in disaster situation, the drone does not find any plain or smooth terrain. So in such areas, how you gonna land the drone and visualize the situation for further rescue operations? So for that thing, what they did actually, they did a wonderful job. They actually created a digital twin of a drone, and then they are actually implementing the same case in a software simulation, where they actually land the drone on an inclined plane, get the data, and see the things. So it was really beautifully presented over there. Now, the slide that you are looking at in front of you is actually kind of a survey. It gives you an overall picture that how much digital twin, quadrotor, and AI has been used in several domains. If we talk about the antenna design and its digital twin, I guess 22,150 articles are there on in several research hubs. If you talk about the digital twin based aircraft detection, 5,604. So these are the categories. It has been shown in a beautiful graph. I mean, people are doing the work, but that is again somehow limited towards some TRL level. TRL level means technology readiness level. So, I mean, this is the power of a digital twin that people are using for particularly for the drone design and for agricultural or energy, or in several domains, the robots or particularly the drones. This data has been acquired until, like, it's updated until 14th of September 2023, like last year, because this is something that is coming from my research paper, which I'll share you in the last, so that you can see, read, and I'm happy. I'm a kind of a person who is really social. So next time when you text me, you will find me that I'm more excited to collaborate, to and more passionate about the research and research outcomes. And this is another graph that actually shows last 3 years context. Like if you can see this column, we have energy directions, we have emerging directions, and we have also the emerging directions here. And then it actually shows the mutual contact. For example, drones, which is used for like a digital twin, and they have been applied. Like they have the discussion regarding AI and digital twin. You can find 7,010 articles on it. Then AI digital twin plus IoT, you will find 512 articles. Then control and observer design with AI and DT, you will find 294. So this actually graph clarify and give you exactly a straightforward path if you are a master's student or PhD student, or you are doing research as a hobbyist, or you are in an R&D company where you are working on drones. You can see that following areas are still vacant. For example, control and observers with remote sensing application. Okay, so this kind of gap is there. You can see we can work on it, and then you can find some of the areas where there is less research contribution. For example, antennas. With antennas, like there are two digital antennas. We are creating two digital twin of antennas, and we are finding the alien agent within the closed or indoor environment or outdoor environment. So this is something that is still needs some more attention from us, from as a researcher. So if we as a control guy, as a robotics and control guy, if we see about the control algorithms that have been doing so good, and at the same time they have some limitations, this is kind of a survey that you can go and see what are the pros and cons. And this is the reason that why I encourage digital twin, because it gives you more freedom, more leverage to see what control, like what is the outcome of your control algorithm. Either you're working LQR, GAN scheduling, H infinity, adaptive control, or any AI technique like fuzzy logic or neural network. So, ladies and gentlemen, this is kind of a transformative concept now that digital twin have been used in UAV communication. It is also used in IoT enabled drones to monitor the construction sites right now. Aircraft detection and then autonomous flight control is also can be possible using digital twin. Then you have sensing and perception is one of the area where your drone sense and see that okay, the drone that is nearby me and following my instructions, whether it is alien drone or whether it is my friend drone. So that is also comes in we can use the ROS or gazebo simulation for it, and we can create the digital twin for this kind of scenario. As I said in the early of my presentation, that now we are in industry 5.0. Our main target is like human and machine collaboration, or human or robot collaboration. So over here I'm mainly concerned with human and UAV interaction. If some person is not good with handling the drone operation, it can be he can turn himself pro in that thing by digital twin, by experiencing different, by implementing different exercises. Swarm control is also there. I mean, recently we have witnessed the Israel and Palestine issue, and then we have witnessed the Ukraine and Russia issue. Today, developing swarm control for every country is it seems, it's my personal opinion, I might be wrong, but it seems that swarm control or swarm of drone becomes immediate need for every country to develop. And many countries are developing it. Like for UK, they have developed Bluebird technology, and there are some other like France, they have developed iQuarus. So we have like number of swarm technology already developed by some of the countries. So this is kind of like one by one I have to define the like digital twin, where you can see experience what is the communication issue with the drone, because we are handling it with a remote, with a ground control station. So whether our drone can be spoofed, can be hijacked, or in other words, in simple words, through our protocol or our control technique or not. We can visualize that thing in digital twin. Regarding the IoT integration, we can see that our drone that has been enabled with IoT can sense the data properly. I mean, it can sense the temperature, pressure, humidity, and can transfer the files, the images, or give the live feed, or the image based results using a file transfer protocol using Raspberry Pi or not. So we can do that thing. And one of the university, I recall, Ulster University in UK, they have developed a project, they call it Matney, and in that particular project they have already developed this thing. So, regarding the other areas, you can detect aircraft detection and navigation. By the way, these areas that I'm mentioning, we are working in it. Our Center for Aviation and Space Exploration has wonderful team from different part of the world under the dynamic leadership of our director. And personally, we are very happy to collaborate. If you have any idea to chip in to collaborate, so these are the trends that I have conveyed to you. Future trends and development is that before you apply, for example, I would like to share my experience. When I was pursuing my PhD is in drones. So my supervisor wanted me to implement the last few objectives, sub objectives on drone by designing it from the scratch. And the main issue that I faced in Malaysia was that when I fly the drone and to somehow, if the payload varies or anything happens, my drone, because of the control algorithm, because it was a testing phase, it actually fell down, and then I have to design it from scratch. The sensors, and because it's very critical for me to think, I always search for the ground, the garden area, where if it fall down, it might not get affected a lot. But so right now, digital twin actually, help you out in these kind of areas where it actually reduces your burden from or redesigning again and again. You test your design in digital twin, see the consequences, see the response, and then implement it into a physical entities in real time. So this is all I have to say, and all the areas that I have mentioned to you are more detailed, in a detailed way. They are described in my review paper. Mainly this review paper or this research that we actually tried to revolutionize the UAVs, either multi-rotor or fixed wing, through digital twin. We are actually in have a vision kept in mind that especially we have to increase the human and UAV collaboration more smooth, more comfortable, and of course, we can, with the help of digital twin, we can come up with the modular drones, or the drones with some add-ons physically, and we can test them in several scenarios. Just like I gave you an example that we have a landing gear for multi-rotors, which can land on any inclined plane using in the disaster situation. Of course, there are some challenges which we have experienced so far by implementing it directly into a practical or real time based drones. But of course, with this evolution, by welcoming digital twin more, I guess we can, resolve these challenges, and may generate a good outcome in with a shorter time span. In last, I would like to conclude that this presentation, this research work would not be possible without the participation of my director, Dr. Abdullah, and he is also the drone expert and a very visionary guy. By the way, this is my paper, that is Digital Twins and Control Theory, a critical review on revolutionizing the quadrilateral UAVs. And in this way, my presentation comes to its an end. Me and Vincenzo, we tried to present our research individually so that we can have more, collaborators, and welcome people who can chip in our respective areas. And of course, as an academic, as a research scholar, we both have this vision that people will get a benefit of it. And if you find our research papers, either of Vincenzo or mine, give it a try to read it, and if possible, let us know how we can collaborate. That's all from my side. Thank you so much for listening.
Thank you so much, Mustafa. So I think now we can take the question from the audience if they have some question. I cannot see any question in Q&A session, but if what you think if we can unmute the all audience if they have any kinds of question.
Yeah, like if anyone has any question, they can just unmute themselves and can ask question either from me or from Vincenzo. Yeah, anyone?
No questions, I think. Let me ask. So
No
we have
question.
to ask something that would be like, about me, just I want to ask. Let me turn on my camera. Thank
Okay.
you, by the way, for your nice talk, guys. I'm really happy to see the nice presentations. And I want to ask something about Barbuto. Though we haven't long discussions, we haven't been long discussions because we are living so far for a long time, so we haven't discussed in detail. Just about the Barbuto, normally in deep learning models or generative AI, it's taking it's a complex model individual. So you build a hybrid model. So my question is, when you making a hybrid model or hybrid, for sure you are going to the concept of the digital twin. So my understanding is like just it's not the question, just curious to know hybrid model. Like when you do a hybrid approach, it's a generative AI, it's a huge thing. Also LSTM, it's also a huge thing. So did you consider something like this if your model will be more complex in the real fields, especially latency? You said in the challenges, like did you think about this? So from my understanding, it's a huge, it's a huge, my understanding, even though just a bit experience, Mike, as I also move in a digital twin, just a bit former, and because I'm working on HVAC controlling smart building, sorry, in my lab, so there is a bit noise. And
No worries.
just I moved in, the digital twin, but the problem is even though I wanna like deep learning models, single deep learning models, LSTM, GRU, or CNN or DNN, I want implementation in microcontroller. It was really difficult. So how do you define in a real field? Like you build this approach, I appreciate, but did you consider this like to implementation in real fields? It's a huge. Just a bit curious to know your
Yes.
discussions about this.
No, you
Sorry,
you're right.
Vincenzo, sorry for interruption. I think it's better if you
Yeah.
can turn just on your camera because it seems like
My camera?
yeah.
It should be on. Can you
I
see
Yeah,
think
me?
it's
perfect.
on.
Camera is
It's
on.
on, I guess.
Oh,
Yeah,
okay,
Vincenzo,
okay,
camera is
okay,
on.
okay, perfect.
Yeah,
yeah.
yeah. No, like you're right, Babul. Like the main issue in this context, if we want to use generative model, is that we have to take into account this kind of trade-off in terms of using edge computing and cloud computing, depending, of course, on our use case. For instance, think about a situation in which you actually have a model that can run in maybe a light model that can run in microcontrollers, right? But then you have to execute more complex tasks. So what is the trade-off in this sense. Like, what can we do in this situation? Like, of course, like you can execute something, let's say, that it's easy to execute, to be executed on the microcontroller at the edge. So using that model. Then you have to study some offloading techniques to understand if the task is too complex. Yeah, then let's offload it to maybe not at the device level. Maybe we can send it to the edge server. If it's even if we require more computation from the device level, we can offload the task to the cloud computing. So the goal here is to use the wall architecture. That's why we talk about the continuum. Of course, it's it's easy to see, but like when you have to implement it, you have to think about it, and you have to study this kind of situation. But yeah, the problem is real. But I believe that we have technologies to overcome it. Like we can actually do that. We can address that. It requires effort, but like it's just about understanding where actually you want to how actually you want to design your system, and based on that, once you decided how to do that, and you also implement some offloading techniques, you're also able to use both discriminative and generative model regarding regardless their complexity in terms of execution. I don't know if I answered your question or your curiosity. You're unmuted.
You are muted, Babul.
You're muted.
Babul, you are muted.
And just a bit, sorry for this. Just I want to ask, did you start to think or did you start to work to implementations your model in a real field? Did you start?
Yes.
Yeah, that's good.
It's challenging.
Okay.
Let's ask the one questions to Golam. Then he said, "Oh, no one asked me questions."
Okay,
And
I think Babul, sorry for interruption. We have already another question in the chat from the Mustafa.
Okay. That's
So,
right. That's nice.
Yeah.
Then we will move towards your second question. So, Mustafa, can you see the question?
Yeah, I can see the question. It is regarding using the digital twin for landing or safe landing in case of crash landing. He's more interested in that particular domain. So yeah, there are some fault tolerant control algorithms which are adaptive robust or adaptive robust. They amalgamated both control techniques or hybridized them, but again that is somehow limited towards experimental setup. I mean, now with the power of digital twin we can experience the same thing without losing our propellers, without losing our frame. So yeah, there are a couple of ideas that I can share. Just Google some of my papers and Google Dr. Zain Anwar and Google Kishore Bingi. So you will find some of the papers that are actually on fault tolerant, like they actually sense the number of RPMs are losing somehow. Then eventually they trigger the control algorithm, which is maybe CI control. People are doing that work already. I have a couple of papers also and research work, but that was something that I did it after losing my propellers, my framework. But since now we have digital twin, so we can utilize the power of DT. Yeah. There is one more question. Most of the work used machine learning in digital twin, but the data set is generated. I guess this question is more suitable for Vincenzo.
Yeah, it
But
seems
yeah,
like most.
Yeah.
before we move, yeah. So maybe you can answer Vincenzo.
Yes. So most of the work use machine learning in digital twin, but the idea, but the dataset is generated from the physical layer. What is the role of the digital layer here? Well, what do you mean by data is the dataset is generated from the physical layer? Like, do you mean that is gathered from sensors or actually generated using AI tools? Because like nowadays, like the thing is that you gather data from sensors spread all over the environment so that you can actually gather all the features from the physical object. And the problem was here actually, because like you rely on data that could be corrupted or missed. That's why, for instance, we decided to implement that specific use case about how to use the Gen AI model to reconstruct corrupted data. If like you, yeah.
Yeah, they should mention the data set, I think. So
Okay. Well, the role of the digital layer here is try to manage in an intelligent way, let's say, all the data that you receive from the physical layer. So the idea is to execute data processing and data analytics based on the data that you are able to gather from the physical layer, so that you can rely even more on such thing. I don't know if I answer your question.
we have third questions, like what are the software and techniques used for the digital twin? I don't know who's going to answer this question.
Yes, like there are plenty of software right now. There are both open source software and let's say private software by Amazon and also Microsoft, but there are also a bunch of open source tools such as is an Eclipse project, and the name is Eclipse Dito. I use it, for instance, for my work or my thesis. But like it depends from you. Like if you want to spend money in subscriptions, there are plenty of softwares. Like the AWS suite tools offers the opportunity to deal and manage with digital twins, but also the Azure Cloud by Microsoft allow you to do that. And but you can also look for open sources project which are actually all over GitHub. I suggest you to find around. For instance, I used this Eclipse Dito, and it was very easy to integrate with my system. Also, I was able to exploit a bunch of APIs for HTTP, MQTT, and several IoT protocols communications. So it was very easy to integrate in my systems. And I suggest you to take a look. I will text in the chat the name.
Yeah, maybe like I'll also add on in terms of robotics and industrial, if you are doing something that is like robots or industrial, you can start with the MATLAB one. And the MATLAB is like most popular thing, but it is like not open source again. We have Hexagon, digital twin solutions. So we have like I remember TwinCat from Beckhoff Automation. We have Altair, not very popular, but in Malaysian universities, Altair Digital Twin is mostly they are using Altair, and University Technology Petronas, from where I did my PhD, they are using Altair. Then we, as he said that Vincenzo said, the salt systems, we call it Delimia, right? So that is also available. We have ANSYS Twin Builder from ANSYS. Microsoft Azure Digital Twin is very popular nowadays. And there is one more. I saw one slide in Vincenzo's presentation. Siemens. So Siemens provide annex with Team
Yes.
Center. Yeah, so that is also one of the robotics and manufacturing, for manufacturing and robotics purpose. They provide some examples also. So you can start with that thing. Yeah. You
There's one
are
more
the
question.
same software used for generated digital twin, or there are some others? I guess it's
Yeah.
for generative. Yeah, it's the same. Yeah,
Yes.
they can
Like
be utilized. Yeah.
yes. Like the goal with generative digital twins is the idea to integrate generative models with digital twins. So like you can use classical digital twin platforms, but of course you have to design how to integrate these generative AI models within your platform. But yeah, the tool are the same. Yes.
Yeah. So yeah. Okay.
Okay.
So
So I think
yeah.
one more question from Bubble. So Bubble, would you like to ask the question here or you want to ask the offline?
Me? No, no, no. It's okay. Just no one asking the questions. That's why I try to ask.
Yeah. No. But I'll be more than happy if you have any question for me. Yeah.
Just the questions. I know you just finished the survey. Like I didn't go to the in very depth, you know. Like when you
Uh-huh.
say just I'm going through, just try to study about your work. And
Yeah.
just I don't have a knowledge in this domain. Honestly, it's a true, you know. Just did you think to possible to apply digital to in I mean generative AI like Barboto did? Is it possible to put on your work like the building model with the generative AI plus deep learning models or whatever you can say? Is it possible to do this?
I guess yes, because the kind of people we are, Vincenzo and me, we can collaborate in future for a better and smarter city. If Vincenzo is doing something on any smart infrastructure, creating a digital twin, and I'm, you know, correlating the response and correlating the performance of construction going on or the progress using drone, and that is again on digital twin. Maybe we
Hmm.
can integrate both domains, and yeah, it is kind of a best solution that we can provide why before implementing. There are various city models that have been introduced right now, like I don't want to quote here the name because of the courtesy, but there are some visionary projects happening in around the world. They say claim 2040, 2050, 2060, vision 2060. So
Mhm.
in that thing, they are quoting that we will build one of the best kind of city, smart city. So I guess before implementing practically and investing so much money, why not you build a digital twin and see the response, like what will be the future, and why not you integrate the digital twin with drone to correlate the response. So I guess somehow in future, but right now if you ask me why I started digital twin, because I was really mad at when my propellers, they are destroyed by several exercises. So I thought that okay, before I'm not going to implement it in practical, I'll implement it in digital twin, and then I'll just see. So I got a good way out by Siemens and some more softwares. But right now I'm using Gazebo a lot, the ROS a lot. So I shift from Gazebo ROS to Siemens as well. So to be honest, generative AI is not. Who knows what will be the future of this path? Maybe if there is a need, I will definitely pursue Vincenzo. I have a very good friend. So yeah, I'll consult with him. Yeah, sure.
Have another question, please. Have a look.
Yeah.
People,
Another question in the okay, I have a
yeah.
question. How good digital twin will be to deal with uncertainties, especially related to UAVs as compared to classical control? Okay, so okay, if you are dealing with classical control, I mean you have some you have already taken some assumptions with your model, with your drone itself, and now when you it on digital twin, but you will sooner face the same consequences if you do the same thing in real. Like if you increase the wind disturbances, because in classical control domain, you would have taken some assumptions of your model, and then when you create the model in digital twin by having the same assumptions, and you are applying PID, classical PID, then of course after certain at a certain stage you will see the stability, your drone will fly from point A to point B, But after that, when you increase the external disturbances or uncertainty, you will face that it's not stable. Yeah, you can implement that thing. I'm planning to make some tutorials also that will be sooner available on my YouTube channel as well. So once I will do that thing, I have the I'll request Bharat to help me to rotate those links, those tutorials to the crowd, to the audience as well. Yeah.
Yeah, sure. It's like if your work is already published and you want to share your slides with the participants, we can also share your slides.
Yeah, sure.
Okay, so I think we don't have any more questions.
Yeah, maybe we can go for a group photo.
Yeah, sure.
Yeah, I request everyone maybe turn on the camera so that we can have a group photo.
I think so. There's one question.
There's one question. Okay, the question is, I'm more interested to collaborate with you regarding implementation of machine learning algorithm, reinforcement learning. Yeah, definitely. I have one paper in line in IEEE Access that is on reinforcement learning. Basically, not reinforcement learning. It is a deep reinforcement learning based or powered PID implemented on drone. So definitely, I'll share with that. Hey, Hasib, long time no see, huh? Assalamu alaikum. Yeah.
Hello,
How's
brother.
everything?
How are you?
I'm good.
I'm
I'm
good.
good. I'm good.
Alhamdulillah. I'm proud of you and watching you after a long time. It's been so long.
Yeah, thank you so much, brother.
It,
Thank you so much.
it feels really good.
Yeah. Let me make a large gallery and then capture the picture, maybe.
Yeah. Okay.
Okay. I repeat again. Maybe like to just notify again to the people if you can open up your camera, we can capture this memorable moment. Yeah. Okay. So yeah, on count of three, all Vincenzo, how you say in Italy, huh? Fratello, right? Brother fratello.
Yes, fratello.
Yeah, so all fratello are here, so we can go like for countdown 1, 2, and 3. Yeah, here we go. Okay. One moment. I'll just put it here. Okay. Yeah, one more. That is freestyle one. Freestyle. Okay. Yeah. Freestyle one, and we go 1, 2, and 3. Okay, done. Thank you so much. Thank you so much,
Thank you.
Vincenzo, for accepting
Thank
the
you.
idea and supporting the thought. Yeah.
Yeah, thank you so
No,
much,
thank you
Mustafa
for
and Vincenzo, both of you.
thank you guys.
Thank you guys for your hard work. I feel proud that we have a very active group. Everyone's so serious.
Thank you, Babul, for your question and for attending this webinar. I'm looking forward to see you in person
In Calabria.
in Calabria.
Yes.
Bye, guys.
Okay.
Bye.
Bye.
Okay,
I just
Vincenzo,
want to say
thank you.
thank you once again for supporting the thought, joining it
Yeah,
from different part of the world.
yeah,
And
exactly.
thank you so much.
Thank you both of you for your coordination, Vincenzo. I don't know what's the time in US now.
It's 10 a.m.
So it's okay for you
Not
now.
too early. Not too early. It's okay.
Yeah,
It's okay.
exactly. Okay, thank you so much. Thank you once again.
Thank you. Bye.
Bye-bye.
Bye-bye. Take care.
Take care.